Chapter 5.5, we're looking at multiple angle and product to sum formulas, and we'll use them to rewrite and evaluate trig functions. So just some of the formulas that we'll need. We're going to take a look at first our double angle formulas. So sine of 2u equals 2 sine of u cosine u. Cosine of 2u, there's a couple ways to rewrite that. But first of all, it's cosine squared of u minus sine squared of u. Then you can get 2 cosine squared of u minus 1, just using the Pythagorean identity, right? If you change this to 1 minus cosine squared of u, you can see how that can happen. And then 1 minus 2 sine squared of u, the same thing, right? So just using Pythagorean identities to get these other two. Then we have tangent of 2u equals 2 over tangent of u over 1 minus tangent squared of u. Now, if you ever were interested in the proof of this, so for example, for sine of 2u, sine of 2 times u, you're going to do sine of u plus u and then use the sum formula for sine in order to derive this formula here. But for now, we're just going to go ahead and use it. So we're going to solve a multiple angle equation. So we need to first rewrite so there's only one x and then factor and solve. So we have 2 cosine of x plus sine of 2x equals 0. So sine of 2x, that reminds us of 2 sine of u cosine of u. So sine of 2x equals 2 sine x cosine x. So we're going to replace that in our equation here. So 2 times cosine of x plus 2 sine of x cosine of x equals 0. So writing as only a single x, so it's not 2x anymore. So now looking at this, we can use the methods we've used before. We can factor out a 2 cosine of x. So we're left with 1 plus sine of x, which equals 0. So then remember, use zero product property. So 2 cosine of x equals 0, and 1 plus sine of x equals 0. So cosine of x, 1 does cosine equals 0. And 1 does sine of x equals negative 1. So cosine equals 0 is here and here. So at pi over 2, 3 pi over 2. And sine of negative 1, well, that is also 3 pi over 2. So we see that the answer is pi over 2 plus 2n pi. And x equals 3 pi over 2 plus 2n pi. So try this example here. Solve cosine of 2x plus cosine x equals 0. So looking at this, you should have used the 2 cosine squared of x minus 1. So with cosine, whenever you see that, you want to pick the one that works out. So we have a cosine here already. So we're going to use that 2 cosine squared of x minus 1, right? For cosine, you have 3 choices. And so I replace that, and then you rewrite it in this form, and then it's factorable. So when does cosine x equal a half, and cosine x equals negative 1? And so cosine x equals a half at pi over 3, and 5 pi over 3, and cosine x equals negative 1 at pi. So here are your answers here. So let's evaluate functions involving double angles. We have cosine of theta of 5 over 13, and we have theta is between 3 pi over 2 and 2 pi. So we want to use the conditions below to find sine of 2 theta, cosine of 2 theta, and tangent of 2 theta. So cosine of 5 pi over 13, and we're in quadrant 4. So we are here, 5 over 13. So 5 is our x value, 13 is our hypotenuse. And so, theta is here, and the right angle is here. We need to figure out our y value. So that is 13 squared minus 5 squared, and take the square root, is y. And so that is 169 minus 25, which is square root of 144, so therefore y is 12, and that will be a negative 12 because we're in quadrant 4. So we know that sine of theta is negative 12 over 13. Tangent of theta is going to be opposite, so negative 12 over adjacent, which is 5. So now to do the double angle formula, so you're just going to have to use the formula. Sine of 2 theta is 2 sine of theta cosine theta. So this is 2 times sine of theta, negative 12 over 13, times cosine of theta is 5 over 13. So let's see, we have 12 times 5 times 2, or 5 times 2 is 10, so this is negative 120 over 169. So it's actually pretty fast. Now let's look at cosine of 2 theta, and so you can choose which formula you want. I'm going to go ahead and use 2 cosine squared of theta minus 1. So this is 2 times cosine theta. Cosine is 5 over 13, and we square it, and then minus 1. So this is 2 times 25 over 169 minus, I know I need a common denominator, so 169 over 169. So that's going to be 50 minus 169. That is negative 119 over 169. Let's do tangent. So tangent of 2 theta, I use the formula, so 2 times tangent of theta over 1 minus tangent squared of theta. So this is 2 times tangent of theta is negative 12 over 5 over 1 minus tangent squared of theta, so that is negative 12 over 5, and we square it. So this becomes 2, let's see, simplify a little bit more. So this is negative 24 over 5 for the numerator. And this is 1 minus 12 squared is 144 over 25. And then I know I need a common denominator, so let's simplify that. So this is now negative 24 over 5 all over 25 minus 144. That is going to be negative 119 over 25. So then we flip and multiply, so a lot of algebra. Negative 24 over 5 times the reciprocal 25 over 119, and that's negative. So negative times negative is positive. Let's reduce a little bit. So negative 24 times 5 is, well, they're negative, so it's going to be positive. So this is going to be 120 all over 119. So try, let's see. Oh, try this example here. Here you go. So use the conditions below to find sine of 2 theta, cosine of 2 theta, and tangent of 2 theta. All right, if you tried this out, you should have found that the x is 4, so here are your other ratios. Sine of 2 theta is positive 24 over 25. Cosine of 2 theta, you should have gotten 7 over 25. And tangent of 2 theta is 24 over 7.